In this lecture, we are going to look at thermodynamics terminology and a couple of the equations that we will be using throughout the course. Thermodynamics terminology is very important because we're using specific terminology to thermodynamics, so it's very important for you to learn these terms now because it will assist in the understanding as we go on. To begin with, however, recall from last lecture we said thermodynamics is a science that deals with energy. And so we talked about energy transformations and different aspects like that. Today what we're going to do is look at some of the laws that are important, and then we will move on to different terms that will be used continually throughout the course. So to begin with, we have the first law of thermodynamics. And this is sometimes also referred to as being the conservation of energy. So what we'll do is we'll begin looking at a closed system form of the first law of thermodynamics. We'll talk in a few minutes about the difference between a closed and an open system. But to begin with, we have Q, which is heat, minus W, which is work, is equal to the change in energy of a system. And remember I said that this is for a closed system. So the units in this equation would be in the units of joules if we're using the SI unit system, which we will use throughout this course. Now, looking at the different terms, we have Q, and that represents heat transfer. And what we will be doing is adopting a convention where Q, or heat transfer, is positive for heat flow into the system. And so the units of heat in this case are joules. Capital W in this equation represents work. And in this case, what we'll do is use the convention of work being positive for work being done by the system. And again, the units here are units of joules. Next, we had on the right-hand side of the equation, we had delta E. Now, delta E is a combination of a number of different properties. So that is the total energy of the system, and it will consist of the internal energy, which we'll denote as delta capital U, plus delta kinetic energy, and we'll denote that with a KE, plus delta potential energy, and we'll denote that with a PE. The units of all of these, again, will be in joules. Now, looking specifically at each of these, delta U, or the internal energy, this refers to the internal energy of the substance or the matter that is part of our thermodynamic system that we're considering. And this would be in the form of molecular motion, So in the case of a gas, we have molecules that are moving around, hitting each other. As the temperature goes up, the molecules move quicker. In the case of a solid, it would be lattice vibration, or even electron motion. So those make up the internal energy of the system. Delta KE refers to the macroscopic motion of the system. So this would be if you have a big chunk of a bunch of molecules and they move together all at the same velocity. Even though the molecules themselves are moving around, this refers to all of them moving macroscopically. And finally, delta PE, that refers to a change in elevation with respect to some reference frame. So those are the terms within the first law of thermodynamics. Next, what I want to do is briefly introduce the other law. Well, there's also the zeroth law, but we won't spend much time with that. We'll look at the first law and the second law of thermodynamics. And the second law we will get to later on in this course. What the second law assists us with is figuring out which direction the energy is flowing within the first law. So it determines So what the second law helps us with is figuring out the direction with which the energy is flowing in the first law, and it also helps us figure out how efficient that process is. And so that's where we will use the second law. So those are the two main laws that we will use within the course. Now what we'll do is we'll move into some of the terminology that will be important for this course.